Today we are going to talk about the AC current, the production of AC current. This is the chapter 9 of your Marine Electricity Handbook. In this episode, I am going to explain how the AC current is produced, the sources of AC current in your boat, and the properties of the AC wave, the shape of the wave. Why the shape of the wave is like the sinus wave. Okay, in chapter 6 I explained how the AC current is produced, and if you remember, I explained that the only way to produce AC current is by means of electromagnets, of magnetism. The only metal, the only alloy with magnetic properties is iron, and all the alloys with iron, like a steel, like a cast iron, any alloy with iron is a ferrous alloy. Those alloys have magnetic properties. How can I create an electromagnet? If you remember, it's too simple. The procedure to create an electromagnet is if you have a piece of iron like this, if you put an insulation material in the middle and you pass a coil through the insulation material and you power the coil with a battery, positive and negative, immediately the piece of iron separates the charge, positive charge and negative charge in each side of the iron. I explained that situation in the chapter 6. Okay, if you have the electromagnet, you can bend the electromagnet like a horseshoe, like this, positive and negative. And right now this is an electromagnet. What happens if you approximate this electromagnet to a coil? If you have a coil and you approximate the magnet and you move the magnet at high speed, the coil produces electricity, AC current. If you have the coil, the electromagnets in front of the coil, and you move the magnets, the coil register the positive and the negative charge and produce the AC signal. That's the procedure to create AC power. Okay, what happens if my magnets are located in a rotor like this, with the rotor positive and negative? You remember the procedure to create the rotor on the alternator? Is very simple. We are going to refresh quickly. I have the piece of iron with the magnetic properties, positive and negative, and I have a couple of washers in a ferrous alloy, and I pre-coated the washers in this way, and I welded one washer in each side, one washer in the positive side and other washer in the negative side. And right now I have the washers here, the iron over there, and I bended right now the washers like this. Oh, the coil is in the middle. The coil is in the middle, washer in the positive side, washer in the negative side, and right now I bended the washers like this with the coil inside. And right now I have this situation. I have the washers bended with the coil inside. I have exactly this situation. If you check here, we have the positives, the negatives, the positive, the negatives, and we have the coil. We have the coil inside. And how can I power the coil inside? Because the brushes and the slip rings. I bring the current here through the brushes into the slip rings, and immediately the coil inside is powered, and immediately those pieces of metal become magnets. And right now, when the magnets are spinning at high speed, if I put a coil around the magnets, the coil registers the AC signal. This is the coil. This is the coil. And right now, I introduce the coil here. The rotor is spinning, and the coil is basically like this. That's the beginning of the coil. Bam, 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 bam. And this is the end of the coil. This is the ground. This is the frame. Oh, the coil don't touch the frame because the coil is separated with plastic insulators over there. the coil never touched the frame. Okay, this is the beginning of the coil, and this is the end of the coil. If I connect in between this end and this end a voltmeter, if the rotor is spinning at high speed, the voltmeter registers the voltage and the AC signal. Or if I connect in between this point and this point a light bulb, when I move the rotor, the light bulb produces light, AC power. This is basically the simple way to produce AC current. Of course, in this particular case, I only produce one phase, neutral and ground. I'm going to explain later what happens if I put in this frame, not one coil, I put 3 coils together, a little separated. I produce 3 phases. Remember, the quality of the AC power depends on the strength of the magnets. If the magnets are weak magnets with low power, the output power produced is low voltage. If the magnets are strong, the output power is heavy power because the magnets are strong. Yes, if I have the coils in front of the rotor, the coil registers the AC signal. This is the stator, and this is the rotor. This is part of the chapter 6. You can refresh in your book those pictures in chapter 6. And finally, in the alternator, the phase 1, hot, neutral and ground enter into the bridge of diodes, and in the other side of the bridge of diodes, the alternator produces DC current. Okay, sources of AC current in your boat. How many sources of AC current you have in your boat? You have 3 sources of AC current. You have the shore power, or you have the generator, or you have the inverter. All of those sources of power produce AC signal, AC current. In a typical boat, those signals enter into the switch selector. Remember the switch selector that we are going to study later in other chapter. The switch selector select if you want to receive the power from the shore power, or from the generator, or from the inverter. And from the output of the switch selector, the current passes through the isolator transformer and enter into the AC panel. The hot and the neutral coming from the shore power enter in the shore power position. If you select shore power, right now the output is directly here and enter into the AC panel. The ground, we are going to study later, the ground never passes through the switch selector. The ground goes directly into the ground bus bar and directly into the bonding bus bar and directly into the sinks. This is the next chapter related with bonding and lighting protection. Okay, what happened when the rotor is spinning, the rotor of the generator? This is basically a generator. When one positive and one negative magnet is in front of the coil. When one positive and one negative magnet is in front of the coil, one cycle like this is produced. Suppose that the coil is here, where my hand is located. When one positive and one negative pass in front of the coil, one cycle is produced. After that, the next positive and the next negative produce the next cycle, other cycle. Each time that one positive and one negative is in front of the coil, one cycle is produced. Other cycle. Depending of the amount of poles and depending of the RPMs, the frequency is more or less. For that reason, we are going to introduce one concept, is the concept of frequency. The frequency is the amount of cycles in 1 second. Is the amount of cycles, the name of each cycle is 1 hertz, is the amount of hertz in 1 second. In American power, the American electricity have 60 cycles. 60 cycles in 1 second. The European power have 50 cycles. 50 cycles in 1 second. What is the meaning of frequency? Frequency is the amount of cycles per second. The American power have 60 cycles in 1 second. The European power have 50 cycles in 1 second. This is 1 cycle. Other important concept related with the shape of the AC power, that shape, is the amplitude. The amplitude is the distance from 0 to the maximum. The amplitude is the voltage. The distance between this and this is the output voltage. The amplitude depends on the amount of turns in the coil. The amount of turns on the coil, and depend of the thickness of the wire, the thickness of this coil, and depend of the amount of coils. Once again, what is the meaning of amplitude? The amplitude is the voltage, the value of the voltage, 120, 240. The amount of that output voltage depends of the number of turns in the coil, and depend of the strength of the field, you remember, the strength of the magnets, and depend of the RPMs of the rotor. It's clear? The amount of coils, the thickness of the wire, and the strength is the amplitude. And the frequency is directly related with the RPMs and the number of poles. For that reason, the formula for the frequency is the number of poles times the RPM divided by 120. The frequency is equal to the number of poles times the RPM and divided by 120. This is the procedure to produce AC power, and those are the concepts that we are going to use in the future. The frequency and the amplitude. Amplitude is voltage, frequency is cycles per second. The frequency is related with the RPMs, and the amplitude is related with the thickness of the wire in the coil, the amount of turns in the coil, and the strength of the magnets. Okay, what happens if in the rotor I have more than one coil a little separated one from the other one? For example, follow me in this explanation in order to understand what is the meaning of 3 phases, or 2 phases, or single phase. Single phase was the previous one that I explained to you. And right now, I am going to explain 3 phase. Okay, in 3 phase, okay, suppose that I have 3 coils. One coil is the black one, the black one, the black one, and finish here. Other coil is the red one. In between the black one and the red one is separated a little. And the red one, and the red one, and the red one, all of those coils, they don't touch together. The wires, they don't touch. Why? Because the wire in each coil is covered with a special resin, a special varnish. That resin is a high temperature resin that avoid that one wire touch with the other wire. Those wires are isolated. Those wires never touch. When one of those wires touch with the other one, the stator is in short, and the output voltage is 0. Yeah. How those protection, that insulation can be damaged? For example, when you overload the generator, or when you produce a short externally in one of the equipments, probably the rotor or the stator is affected, and the temperature of the wire increase, and the varnish is cracked, and the cables, the electricity pass from one to the other one and produce the short. Don't forget, those wires are properly isolated. The wires, they don't touch one with the other one. Okay, suppose that this is a single phase coil. I have the hot, the ground, and the neutral. This is the beginning of the coil, and this is the end of the coil. That's the hot and the neutral. Suppose that I have an stator not with one phase. This is one phase. I have an stator with 3 phases. One phase is the black one, other phase is the red one, and other phase is the green one. Each This is the beginning of each phase, and the end of all of those phases are connected together, and that one will be the neutral in the future. The end of the green finish here, the end of the red coil finish here, the end of the black coil finish here. All of them are together, and that one will be the neutral in the future. And this is phase 1, phase 2, and phase 3. Because each phase is winding in a different angle with respect to the frame. Each winding is located some degrees separated from the other one. Those degrees of separation between each phase they are the phase angle. The phase angle. Okay. In this particular case, the red phase is produced in this position. The black one is some degrees separated, and the green one some degrees separated. This is the black, this is the green, this is the red, yeah? They are separated some degrees. The phase angle. What is the value of the phase angle in a typical three-phase motor? The phase angle is in between 1 degrees and 8 degrees. The bigger phase angle are the motors that produce higher torque. A smaller phase angle, a smaller separation between one coil and the other one, produce higher speed but low torque. More separation in between the coils produce more torque and less speed. Yeah, this is basically the explanation about the phase angle. The phase angle is important. Because when you select the motor, because in the design you need a motor to produce high torque, probably you need a motor with a higher phase angle than other one. Okay, this is the typical explanation in order to produce three phases. There are other type of outputs of AC power. Normally, if the AC power is a pure power, like the power produced for a generator, the shape of the wave is like the sine wave. But there are other sources of AC power, and those sources of AC power produce other output shapes. Like this, square output or triangle output. This is the case of the inverter. The output of the inverter are those signals. Those signals are not good in some situations. Those signals work for electronic devices like cell phones or laptops, but those output signals are not good to power a compressor of an air conditioning equipment or to power an electrical drill, yeah, because those signals are fictitious signals produced in a circuit board, no produced for rotation of electromagnets. Those output signals doesn't have frequency because those signals are not produced for rotation of electromagnets. This is the output of the inverter, and we are going to study in the chapter 15 inverters, and I am going to explain in that episode in details how the AC power is produced in an inverter. Remember, the inverter have in the input batteries and in the output AC power. This is the output power from the inverters. It's a fictitious power. That power can be used in some applications, and it's not recommended for other applications. The angles, you remember the three phases? Each phase is produced in a different angle, and this is the phase angle that I explained before. Okay, I hope that you enjoy this chapter.